So, for problem number 9, it says Isaac Newton was able to estimate the value for the universal gravitational constant from the following data: radius of the Earth, the average density of the material of the Earth, and the fact that acceleration due to gravity is 9.80 meters per second squared near the surface. What value did Newton obtain? Well, I researched this, and I haven't found any evidence that Newton actually did this. So I'm going to pause and we'll start back in just a second. Okay, so let's have the Earth, and it's a sphere. And it has some radius called r sub e. So the volume of a sphere is 4/3 pi r cubed. So we can find out then the volume of our sphere. So doing the substitution for this problem, that gives us a volume 1.098 E21 cubic meters. And from this value, we're going to calculate the mass of the Earth. Okay, since we have density times volume is equal to mass, then density is 5.50 grams per cubic centimeter, and this is in cubic meters. We're going to have to do a conversion. So this is Greek letter rho, which we use for density, and we know that there are 1 million cubic centimeters in 1 cubic meter. Now you get that by having a cube, length, width, height of 100 centimeters on each side, and then 100 in the z-axis. So x, y, z. 100, 100, 100 is 1 million. And then we're going to have grams, 1 kilogram per 1,000 grams, and this gives us a value of 5.50 E6 divided by 1.0 E3 gives us 5.5 E3 kilograms per cubic meter. So this value times this volume, density times volume, is equal to mass. So we're going to get the mass of the Earth is this density, 5.5 E3 kilograms per cubic meter, times 1.098 E21 cubic meters, gives us a mass of the Earth 1.098 E21 as 6.039 E24 kilograms. All right. The logic is that since force due to gravity is G-M-E-M over R-E squared. We're going to do a substitution. Let's say that we have a mass of 1 kilogram, and that mass of 1 kilogram has a force of 9.8 newtons. G-M-E 1 kilogram over R-E squared. Now we're going to solve for G. So 9.8 newtons times RE squared divided by ME, 1 kilogram, is going to be G. And as I alluded to earlier, there's no evidence that Newton actually did this. He may have, but I have no knowledge of that. Okay, so do our substitutions. And so I've got 9.8 times R squared, which is 6.40 E6, and we're squaring it, and divide it by 6.039 E24, and that gives us a value of 6.65 E negative 11 Newton meters squared per kilogram squared. And that's the value we obtain for this problem.